So it's nice.
Sure, yeah, no, absolutely.
It's nice.
Yeah, I think it is good to have.
Yeah. Especially such an interesting talk. So we're just going to give it a few more minutes because people are still dropping in. Yeah. Yeah, should we just start because there's already quite a lot of people and it's been 3, so maybe
Sure.
just kick off.
Yeah.
So hi everybody, welcome to the Consciousness Club. I am very excited and happy to be back. I've been away for the past 6 months because of long COVID, but back in action, and it's really nice to be able to open with such a cool speaker as we have today, Jorge Morales, and I'm sure that I am butchering his name, so please bear with me. Okay, that's good. So Jorge is an assistant professor in psychology and philosophy at Northeastern in Boston, where he leads the subjectivity lab. So the name of his lab clearly shows the relevance of his work for the audience of the Consciousness Club meetings. Subjectivity, the best thing, the most interesting thing. And Jorge's research integrates tools from psychology, neuroscience, and philosophy to study the interplay between perception, consciousness, and introspection. And before joining Northeastern, he earned his PhD from Columbia University and was a postdoc at Johns Hopkins. Jorge was born and raised in Mexico City, where he also obtained both his undergraduate and master's degrees. And today he is going to tell us about the varieties of metacognition. Take it away, Jorge.
Thank you so much, Nadine, for introducing me, and thanks everyone for being here, and thanks for the invitation, Steve. I'm super thrilled to be talking to you today, talking about cool names. The Consciousness Club is just on top of the places I've been invited to speak at, and I'm really excited. And I should start by saying, Nadine mentioned that my work integrates philosophy and neuroscience and psychology. And this talk is going to have a little bit of everything. I think for the most part, I'm going to be wearing my philosopher/theoretician cap today, although I've been talking a lot about empirical data, some of it collected by myself and some of it just reporting on colleagues' work. The other thing that I wanted to start with is that, although I'm very excited about this project, I'm aware of the fact that I'm coming to the Lion's Den to talk about metacognition. So I hope that people here find the talk at least inspiring for thinking about why it's all wrong. So with that in mind, maybe I should start. And okay, so the ancient Greek had these very famous maxim inscripted in the temple of Delphi, know thyself. And they took it very seriously, and I think we should do too. And in modern times, one way in which psychologists have translated these maxim into an empirical program has been in the guise of metacognition, studying the ability to monitor and control our own cognitive processing. And this could look very different depending on what we're evaluating. So for example, one can monitor and control our perceptual states. We experience visually our world around us, and then we try to evaluate how reliable that visual information is, maybe by being sure or unsure of what we're seeing and therefore acting accordingly. And we can do this with other modalities as well, not just vision or other types of perception. We can do this with cognitive stuff. For example, with memory. If you're studying for an exam and you're trying to determine whether it's time to stop or whether you should continue studying, you need to implement your metacognition of memory, like how well encoded the information is such that you can either keep studying or stop and go to the pub with your friends. these are just a couple of examples of how metacognition look like. And the crux of the talk is going to be asking how many kinds of monitoring there are. In other words, when we do metacognition over different cognitive states, is it a single domain general capacity that we leverage to evaluate whatever we're doing? So for example, when we evaluate our perceptual states or cognitive states, maybe some other embodied states like our emotions or motor actions, are we using a single capacity that it just happens to be applied to different domains? Or alternatively, are we dealing with a series of capacities that are maybe related in what they are doing, but separate in how they operate and how they interact with each particular cognitive process? And that's going to be the question of today's talk. Which of these two are, which one is the correct answer, as it were? So the plan for today is first to just say what is domain generality and domain specificity and why they matter. Then I'm going to move on to present necessarily abridged summary of empirical evidence that we have for and against the possibility of a domain general metacognitive mechanism. And then I'm going to reflect on what is the probable domain specific nature of metacognition. So just to lay out the cards, I think that it's more likely, given what we know at the moment, closer to the domain specific series of general domain general matter. It's very easy to explain domain specificity when we talk about perception. For example, being good at seeing something.
Jorge, your lines
doesn't tell us anything.
Your line is pretty bad.
How good you are at hearing.
Hello?
We lost him.
Oh no. Steve, can you take over?
Yeah, metacognition is domain general, and then we can all go home. No, that's a joke.
Can you hear me now?
Yeah, it's been cutting
pretty,
on and off. Yeah,
it's been breaking up a little bit.
Oh no. Okay, should I go back a few slides maybe?
I think maybe just one slide back. Do you think the connection is okay now?
I just switched networks. I hope that helped.
Okay,
it does feel better. Okay, great.
Okay, well, do let me know if I cut off again and I can try something else. Okay, so I was just saying that, so the first part of the talk is trying to understand what I mean by domain generality and domain specificity. So in the case of perception, it's fairly easy to show what I mean. When you see something or how well you see something, really doesn't say anything about how well you can hear something. Our abilities to see and our abilities to hear are pretty separate. And of course they can interact, but they are for the most part separate mechanisms that operate independently. And perception as a whole, also operates to a very large extent independently from other cognitive abilities like memory or language, right? Like how good your language skills are, it doesn't tell us anything about how good your eyes are or how good your ears, how good your hearing is. Whereas, for example, in the cognitive domain, it's easy to find cognitive abilities that are more domain general. Consider working memory, where you can keep in mind, for example, hues of colors, but also things like words or things like numbers, which are like very different, right? Whereas in perception, which is domain specific, usually you can only see visual properties, you cannot see auditory properties, you cannot see haptic properties and so on. You can make inferences based on vision about those properties, but really the vision is focused on visual properties only, whereas memory seems to be able to incorporate things from very disparate domains. Or consider language in terms of like what language can be about. We can talk about atoms and things that don't exist like Santa Claus and rocks and abstract things like democracy. allowing us to the range of language is like fairly broad. Or maybe one of the most or the most recognizable domain general abilities is intelligence, where it's basically once you have a certain amount of it, it seems to be something that applies across the board, different aspects of our mental life. Like, for example, if someone with a certain amount of intelligence, things like their working memory, processing speed, pattern recognition, spatial reasoning, creativity, and so on will be correlated, suggesting that they all fall under an umbrella of intelligence, or allowing intelligence to be of certain domain general character. And now the question is, why does it matter if any capacity, but metacognition in particular, is domain general or domain specific? And I think that there are theoretical reasons for caring about this question. One of them is that it's just really about something that we have to learn about the architecture of the mind. Like, whether it's one way or the other, tell us in which way we can understand our minds. But also, it tells us what kind of process metacognition is. Is it more like language and reasoning? Is it more like a cognitive ability? Or is it more like perceiving, a more sensory capacity, as it were? Or not, even if it's not sensory itself, does it behave more like our sensory capacities? And in practice, it also has a lot of consequences. One of them is that it allows us to make predictions. If metacognition is the domain general and you know something about how it behaves in one domain, you can make fairly good inferences about how it will behave in another domain. Just as if you know someone is intelligent and you know that their working memory is good, you will know that they're going to be good at pattern recognition as well. It can also allow us for training, right? Like if metacognition is trainable and it's the domain general, you can train in one domain, and the benefits should spill over for metacognition in other domains as well, because it's the same capacity. In clinical context, it also matters if metacognition gets affected and it's domain specific. It might just affect one domain, how you introspect in one domain, but not the others. The other might be spared, whereas that won't be the case if it's domain general. And finally, in very sometimes hotly debated questions about artificial general intelligence lately, the question of whether a capacity is domain general or domain specific, whether you have to train for various different separate abilities, or whether you can get one big, as it were, network that can do everything, it's really relevant. And I think that also applies for metacognition. Can we, for example, if we were to implement an artificial system that has some degree of metacognition, do we need to train it for each of the abilities that it has, or can we just provide it with a domain general metacognitive ability that will just be easily applied in the same way to all of its different abilities? Okay, so that's the first part, just laying out the groundwork and the questions that I'm interested in today. And then most of the talk I'm going to spend in the next two sections, and I'm going to jump in directly into empirical evidence. And again, it's obviously biased and abridged by necessity, but hopefully it can paint a general picture of how I see the literature these days. So how do we study metacognition in the lab? This is a perceptual task, and many people in this room don't need a reminder of how this is done, but let me just go quickly through this experiment or like mock trial. Participants would see two types of stimuli that vary, for example, in one visual feature, in this case, the brightness of the word on the screen, and their task is just to select the brightest word. So let's say that they select artist. And if they do that, they will be correct, and they can then judge how confident they are that they got the answer correct. So in this case, they might be in a scale of 1 to 4, very confident that they got the answer right. The trial was very easy. In a slightly harder task, where the brightest word is sable, but it's like very hard to tell, they might still be right about it, but maybe their confidence is lower because the task was harder. Similarly for memory, maybe you give people a few words to memorize. I'll let you try. And then you ask them, of those words, which one is the one that appeared, oops, maybe we have to go through the whole thing again. Yeah, if you show them some words, you show them which one of the two were there. Truth was the correct answer, but maybe someone made a mistake and select logic, but they know that their answer wasn't probably correct, and they go for a low confidence rating, and so on and so forth. And you can use these basically for any task, right? Where you have to do something, there's an objective, correct answer. You can always ask subjects to evaluate their confidence and therefore use their metacognition. And the nice thing about these sets is that you can have a first order or type 1 task where you can have a right or a wrong answer. If someone says left for this right word, then they are correct. If they say right, they're wrong. But you have a second higher order answer where you evaluate your confidence, and you can be right, for example, if you're sure of a correct answer, but you can also be right metacognitively speaking if you're not sure of an incorrect answer, and vice versa. If you're sure of a wrong answer, metacognitively, that's not good. Just as it's not good to not be sure of being correct, right? And we can use these relationships to quantify how good your metacognition is. A popular measure that has been used recently, it's using meta D prime or M ratio, which is meta D prime divided by or normalized by how good you are at the task. And the details don't matter too much for today. It's just important to know that it's a measure of metacognitive efficiency, how good your metacognitive ratings are tracking your performance, right? And the nice thing about that is that it gives us a number that then we can use to correlate across different domains. We can use a straightforward correlation and basically try to look for domain generality by looking if these metacognitive efficiency changes more or less in parallel across different domains. We can infer that that's because the underlying ability is correlated. So let me expand on that a little bit more. Imagine that metacognition is domain specific. That means that there are different separate ways in which you evaluate your confidence, depending on what domain you're evaluating. And if that's the case, then if you correlate the metacognitive efficiency in each domain, or maybe some brain neural activity measures, you shouldn't find that these are correlated. They might be similar in some subjects, but if you look at a population, you should see variations that are not correlated across these measures across domains. So a correlation in metacognitive efficiency across two domains might look something like these, like fairly uncorrelated. This is like an extreme case, of course, but it's for illustration purposes only. Whereas if there is a single domain general mechanism that it's used for evaluating confidence in every domain, then you should expect that brain measures and behavioral measures are somewhat correlated. They should be fairly similar. Maybe there are some differences because the domains are different and whatnot, but overall there should be some strong measure of correlation, something like these. Again, like an extremely good case. Now, what does the empirical evidence look like? Take this example from Sarn and colleagues from a decade ago. They asked subjects to detect the orientation and contrast of these gradings and then rate their confidence on how good they're doing in the task. And perhaps unsurprisingly, the correlation was extremely high, right? Like evaluating how confident you are that you're good at a contrast task and how good you are at an orientation task are fairly correlated. Both are visual tasks. And this also happens when you go across perceptual domains, at least that happened in these experiments by Nathan Faber and colleagues from a few years ago, where vision, hearing, and touch had similar profiles of metacognitive efficiency. And similar for interoceptive ability, like how good you are at detecting your cardiac rhythms and your respiratory rhythms is very correlated. Not just how good you are at detecting them, but how good your metacognition of that ability is. And in these meta-analyses, where more studies were included, it just seems like meta-perception is the main general in that sense, right? Like the ability to detect or evaluate your confidence across different domains is correlated when you're in the perceptual domain. And recently, Steve and colleagues found something very similar, not just within perception, but across perception and cognitive domains, including semantic memory, executive function, and episodic memory, like highly correlated metacognitive scores across these domains. And all these, of course, points towards domain generality. There's a study of of my old lab that a perceptual and a memory task similar to the one I showed you earlier. And when they looked at their confidence, metacognitive efficiency correlation, it was extremely high. And of course, once again, this was evidence for perception and memory similarity, and therefore domain generality of metacognition. And this would have been very exciting back then if it had not been that in the same year, in exactly the same journal, a different group published these results of a similar perceptual and memory task where the measures were like completely non-correlated, right? And this was literally, it was a funny coincidence that it was same year, same journal. And this probably would have been like very surprising or quote unquote devastating for my old lab, had it not been that in the same paper, they found that when you looked at brain measures, these were not correlated. So these really set up like a program, again, that some people in this room have been part of, that really asks, excuse me, really put everyone on a spin to say like, okay, which one is it, right? Like, how do we tell whether metacognition is domain general and domain or domain specific, but also should we trust brain measures over behavioral measures or vice versa? Do we need to find convergent evidence? Do we need to do new tasks and so on? So I'm going to tell you about how that story went. And the first thing was noticing that if these brain measures suggesting that there are different neural correlates of metacognition for memory and perception is true, we should be able to find dissociations. So for example, if prefrontal cortex where perceptual metacognition apparently lived was damaged, then we should see diminished perceptual metacognition while memory metacognition remained intact. And this is something that Steve tried successfully by looking at prefrontal cortex lesion patients, 7 of them. And what he found was really interesting because when we looked at type 1 performance, how good people are at doing perceptual and memory tasks, controls and PFC patients and brain lesion patients with a lesion in a different part of the brain were all pretty similar. So they could all do the task fairly well. But when they looked at metacognitive efficiency, what Steve and colleagues found was that temporal lobe patients and controls, they were fairly fine, right? Like their metacognition was fine for both domains, but perceptual metacognition was heavily impaired in PFC patients while memory metacognition was spared. Again, that while first type 1 performance was intact, which is a huge piece of evidence suggesting that metacognition is domain specific. And of course, this begs the question, which is, can we get a double dissociation? Can we get the reverse degree of damage, diminished memory metacognition, and intact perceptual metacognition? And recently, Hakwan Lau and colleagues found that if you TMS and disrupt neural activity in the precuneus in parietal cortex, where memory metacognition is hypothesized to have a significant role, memory metacognition, it's impaired compared to sham shock on the vertex, whereas perceptual metacognition, it's safe, right? It doesn't get affected. And I just want to highlight that in these in these experiments, they not only found that metacognition for memory gets significantly impaired when TMS is delivered to the parietal cortex, they also found that before the TMS, the metacognitive efficiency measures were correlated between perception and memory that you can see here in green, but that correlation gets broken once you affect the pre-news. And this is really significant because it tells us something about what does it mean to find a domain general looking correlation in the brain, right? Like we might behaviorally find some correlation, but once we disrupt the brain, we notice that that correlation, I'm not saying that it was spurious, but it might have been supported on something that it's not the same neural mechanism supporting different types of metacognition. Because once you break one, that correlation stops, stops being true. And Steve Harper and I also at some point looked at metacognition across domains with fMRI. And we really tried to get, and this is going to become relevant later on, we really tried to get the task as similar between perception and memory. We put a lot of effort at matching the stimuli. In this case, we use words for the visual task where we change the intensity of the word. And in memory, we use, of course, words. But we also use abstract shapes, right? So that we don't favor memory and words, for example, or the language centers of the brain are playing a role and so on. And we really try to match performance between perception and memory by thresholding tasks. So people were equally good at doing the perceptual and memory task. And yet, what we found was that when we compared metacognitive efficiency across perception and memory, they were not correlated at all. And when we look at the brain, we used MBPA, multivoxel pattern analysis, which allows us to look not just at how active a brain region is, but also at finding patterns of specific activations that might tell us more about how the brain represents certain cognitive activities. And the idea of leveraging machine learning here was to ask the following question: can we infer neural patterns of memory metacognition from perceptual metacognition patterns, and vice versa? And the reasoning behind this was, look, if we train a decoder to separate proper confidence making from a control in the perceptual case, can we use that decoder to classify confidence in the memory case? And the reason was, if we can cross-domain classify, that means that the pattern in the brain are similar, and therefore there might be some shared metacognition. Metacognition might be domain general. Whereas if we fail to do these, and yet we're able to classify within a single domain these patterns of brain activity, that would mean that maybe metacognition is more domain specific. And we did find some domain general cross-classifiable mechanisms, the ones in yellow. And I should point out that because of the regions where we found these, like the dorsal ACC or insula, it is likely that what was classifiable was a general level of uncertainty, as it were. Like there are some shared mechanisms that the brain uses for assessing general levels of uncertainty, but we really couldn't get like more specific brain regions for domain general metacognition, whereas we were able to find very specific and large strides in the prefrontal cortex for specifically domains for perception and for memory, sometimes even overlapping, right? Like so sometimes even in the same region, the patterns of activity were very different, and yet they were not cross-decodable across each other, suggesting that it's really very different metacognitive evaluation that it's happening depending on what you're evaluating. Again, indicative of a domain-specific mechanism. Now, just this year, we tried to leverage like big numbers, as it were, and we made use of the confidence database, which is this beautiful resource originally organized by Toby Rachnev, and then tens of people contributed to it and keep contributing to it, providing us like lots of data on metacognitive experiments that we were able to use, and thanks to all being open sourced and a fantastic intern in the lab, Suresh, helped us analyze this data. And we basically looked for multi-domain experiments where the same subjects used did more than one experiment in different domains. And we were able to find 9 of those studies that had at least 2 or more domains, which boiled down to 28 experiments and allowed us to make 33 pairwise comparisons. So that's a lot of possibilities of finding domain generality. And even though perception and memory were dominant, we also had like motor control, inference, and different types of memory too. Overall, we had 400 subjects and over 100,000 trials in the analyses. And this is more or less what we found. Take study 1, just bird's eye view of the correlations. It looks like at least one of them seems to be like showing some sort of like correlation there. The other 2, not so much. Study 2, pretty flat correlations across the board. Study 3, this one was like highly correlated. Then when you look at the other experiments, like not so much, some of them even anti-correlated. And when you keep adding all of the ones that we did, I think the gestalt picture that emerges is that it's really not a lot of domain generality that we can find in the brain. We found 7 significant correlations, but I should add a caveat, which is of those 7, really only 1 was like meaningful. 2 of them were difficult to interpret because they were negative. So it's hard in this context to make sense of a negative correlation. And the other 4 were included in the analysis because that's how they were labeled in the database. But once we looked into what the task was, it really was not 2 different domains, right? It was more similar to the orientation versus contrast that I showed you before, which is, well, surely those are different tasks, but they're both very basic visual tasks. So those 4 that appear to be 2 different domains, they really are just the same domain. So it's kind of unsurprising that they are correlated. And we found the same, whether we used one type of pipeline or we used a more sensitive one. Steve recently mentioned on Twitter that one thing that we can do is use group level instead of single subject fits to reduce some of these variants. And that might actually increase the degree of correlation between these tasks, especially given that some of these experiments were not specially enhanced for this kind of question, right? Some of them are fully powered, some of them don't have enough trials and so on. But still, it's fairly telling that with kind of like some standard way of analyzing data, it doesn't look like we actually get lots of domain generality.
Oh, wait, can I just ask?
Oh yeah, please go ahead.
Just while you're on that slide, I was wondering why the variance is so large for domain 1 compared to domain 2.
Oh, interesting. Yeah. I think that actually it's the same here. It's just that it's similar at least. It's just that I left the axis is similar to the previous one just to make it more comparable.
Sorry, it's an axis. It's an axis thing. Yeah, okay.
Yeah, it's like basically the left-hand side is empty. I told you about it. Like I just wanted to make sure that it to show how like actually the variance got compressed with the H meta-analysis. Yeah.
Sure.
Yeah. So the next question that we wanted to ask was, okay, how similar is memory and perception? Like not for the same subject, because there were only a few studies that we could use where the same subject did both tasks, which is what you need for doing a correlational analysis. But just overall, what happens if we look at all the memory and all the perception trials in the database, which expanded how many studies we could include, in this case, most of them, which is fairly telling in the sense that most people are studying only these 2 things for in metacognition, whereas our cognitive abilities are like way beyond these 2 tasks. Because also in perception is mostly just visual perception, which allowed us to include like over 7,000 subjects and almost 500,000 trials. And when we did that, we found that even though somewhat similar, meta memory was always better than perceptual metacognition, right? Like it was significantly different in a way that I don't think it was like, it's not a super big effect, but it's like a almost 0.2 Cohen-Dees difference between these two, which at least for psychology standards, I think that it's like, it's a small but fairly common size effect for things that we think matter. And this is really a question I'm going to come back to later, which is why do we keep finding metacognition for memory to be better than metacognition for perception? And the reason why we went into these analyses is because I had this impression from just reading the literature, like, oh, that's funny. Like memory is always better. That's funny. Even when the task performance is matched and so on. And when we looked at all these subjects, it seemed to corroborate my intuitions that these two capacities don't seem to be similar. So, of course, that closes what I wanted to present in terms of like empirical evidence that it's kind of I play with in my mind when thinking about these questions. And I want to now move on to reflecting on what this means, right? Like, what does these data probably indicating the domain specificity means, and what can we do with it? First of all, we're using Pearson's R as a way of assessing these, right? And whether we use like direct measures or like slightly fancier methods, it's still in the end a correlation that we're looking for. And of course, that begs the questions to what is the threshold for considering something correlated or not? Like we could use significance, right? But what if it's like a correlation of 0.01 that it's highly significant? Is that something that we should care about? Is that going to tell us about how correlating these are? No, then what's the threshold for us for calling something correlated or not beyond significance? Take these. This is actual data. I didn't want to put like the author's name, just because I don't want to. It's not a problem with this paper. I don't want to single out anyone, but I'm really curious about what's the significance of a 0.09 significant correlation in terms of these two abilities being similar. And of course, it might be right. Like maybe not for one person, but maybe in a population, maybe for some treatment, it might matter if it's this small of a correlation. But I'm just not totally sure that a correlation this small, it's going to matter for us in practical terms for things like in the clinic or for training and so on, right? So we should not confuse the tools that we use for determining something with the actual phenomena that we care about and how significant it is. Now, if metacognition is domain specific, or really domain specific, that begs the question, is the number of metacognitive mechanisms going to be equal to the number of cognitive capacities? In other words, are the options really like either domain specific or domain general? And if it's domain specific, does that mean that every single capacity is going to have its own metacognitive embedded ability that is separate from the rest? I guess that's possible. There's nothing, I think, that prevents that from being true, but maybe it's slightly implausible, or it might just be very hard to grapple with that. And I think that's something, first of all, one thing that I want to highlight is that even if something is domain specific, that doesn't mean that it's not the same type of mechanism, right? At least at some level of description. So think about perception. Vision and audition are extremely different in many ways, but we can describe both using signal detection theory fairly accurately, right? Like both are mechanisms that are, to a very large extent, detecting signals and separating it from noise in the environment. So at least at that level of description, the mechanisms behind perception and memory are very similar, even though they're doing very different things and they're actually separate mechanisms. So this could be true for metacognition as well. The fact that they're domain specific, it doesn't mean that they're not doing exactly the same thing. And the brain is good at reusing similar mechanisms in different ways. So it wouldn't be surprising that that's the case. But then the other thing that it's important to highlight is that there could be clustering, right? Like it doesn't have to be like massive domain specificity that we're talking about. It could be the case that all types of perception is evaluated with a signal mechanism. Like something that is, look, if it's information given to me from the outside world, then metacognitive mechanism 1 evaluates that. Polina Arbuzova and Elisa Filevich like tested this hypothesis recently. It doesn't seem to pan out that well, but it could be, at least theoretically, that there is some sort of like inner versus external axis, as it were, where metacognition becomes grouped. It could even be, and in that case, so we could ask, is being domain specific versus domain general research that needs to be calibrated? Like, what is the difference between that, right? Like, it could be obviously the case that metacognition is domain general, but it's also not magic, right? It's not that there's a magic metacognitive mechanism that as soon as you apply it to different domains, it's just going to work in exactly the same way. It might be that it's a single mechanism that, however, experience and so on, like really matters for how effective it is and how likely it is that we find a correlation. And I think that this really shows up in this plot, where it just seems that people are better at evaluating their memory. And I really wonder why that is. Of course, one reason could be because there are different mechanisms, and on average, the mechanism for memory is better than the one for perception. But it could also be that we're more used to evaluating our memory than evaluating our perception, at least in the ways that we do it in the lab. Imagine that you go to the lab and you've never done an experiment, and people tell you, okay, you're going to evaluate how confident you are in things. And one of the tasks is evaluating the orientation of a grading of a Gabor patch. And the other task is like, oh, please learn these words and then tell me how sure you are that you remember them correctly. Those are like just massively different tasks in terms of how familiar subjects are with doing them, right? One of them is very similar to everyday life. The other one is not. Steve and I tried to play with these and did our best, right, at matching these, trying to make the task a little bit funky with the shapes and make sure that it was the same across perception and memory. Other people have done that too. Hakan Lau, for example, in this experiment, in the perceptual task, I think both used like videos of a video game. And in which case, in the perceptual task, they made one of them blurrier, and in the memory task, subjects just had to remember which scene came before the other one. So the stimuli were the same, or these abstract shapes in the bottom also they were trying to match. But I think that in those cases, what we're controlling for is performance and similarity of the stimulus, but not the task itself, how familiar you are with evaluating memory or how familiar you are with evaluating perception. And I think that that's something to think about, right? Like, I wonder if we get like expert like TSA agents that, you know, look at X-rays of like suitcases going through airports, if you give them a visual task, I wonder if they're just going to be better at evaluating the metacognition than for a memory task, even though in general the population tends to be different, right? And it's not that they're specialized for that particular type of X-ray images. It could just be that evaluating perception, it's more familiar to them. They know what to look for, what signals to pick up on, and so on. So I really think that we need to make an effort as a field to control for familiarity with the type of task if we were going to get at this question in a better way. And going back to this slide, this result where TMS disrupted the correlation between two tasks, it really suggests to me that even if domain generality is there, it's kind of fragile, right? It seems like once you, and same with like patient lesion patients and so on, it seems like once you lesion certain areas of the brain, this correlation breaks down, which suggests to me that it's not that it's a single mechanism that it's operating across domains, but rather there are kind of related mechanisms that maybe have some shared resources, which might explain the correlation that we're finding, but it's less likely that it's like literally the same mechanism operating across domains. And the other thing I wanted to mention is, and this is a little bit in the weeds, but it seems like whether we find a correlation or not, it's really sensitive to what type of task people are doing. People have found like a 2AFC task versus a yes/no task, like really breaks or brings in a correlation. or even analysis pipeline. Like if you analyze metacognitive efficiency, like with or without a log, it changes the correlations. If you use maximum likelihood versus Bayesian method, it really changes that. And of course, we want to use the best method. We shouldn't expect that any method should throw a correlation. But the fact that it's so sensitive to how we decide to analyze the data makes me a little bit worried about whether we're reading tea leaves or not. And going back to something that I said before is, let's assume that I'm wrong and I'm being too oversensitive to what like the literature looks like, and maybe there is domain generality. Given how fragile it seems to be and the size of the effects and so on, I wonder how much does it matter in practice, right? Consider intelligence. Intelligence seems to be this thing that it actually really predicts a lot of things. And, you know, it's a controversial topic, whether this really actual G thing that it's, you know, underlies everything or not, and to what extent it depends on how we measure it and so on. But actually, IQ tests they do predict a lot of things. Just going to Google, like, the completion, it's really big, right? It predicts a lot of things, including Reddit somehow. I don't know what that is, but the other things seem legit, right? Intelligence predicts performance, health, longevity, mating success, mortality, personality, mental health, and so on. So I wonder if, I mean, metacognition is a very young field. We're doing a lot of things that are really exciting. And there have been some things that have been found to be correlated with metacognitive ability, right? Like in mental health, for example. But again, that has been tested for one or two domains, right? Like, is it that visual metacognition predicts anxiety? Like maybe, but does that mean that these domain generality is going to happen across the board with different mental health outcomes or with different types of metacognition? In other words, for those studies who have found some correlation between metacognitive efficiency and mental health, had they used a different domain in their task, would they have found exactly the same outcome? And I don't know the answer to that. I feel that the answer is no, but I think we need more data for that. And I just want to end with like maybe a word of caution in how we think about, or like just a way of like, maybe we should try to resist the temptation of domain generality, because we've been down this path before for other things. Those far transfer exists. Negative evidence from chess, music, and working memory training. Training does not improve performance of intelligence. No evidence of bilingual executive function advantage, and so on, right? Like we've tried to do all these things where, well, maybe if you study a second language, you become better in executive function. Or maybe if you train working memory, then you become like more intelligent in general. Or maybe if you teach children chess when they're young, they will become more intelligent. And the answer for that seems to be like a very big no, even for things that are within cognition, that seem sort of related, and so on. So, and the consequences are not trivial, at least for intelligence, but I think for metacognition, given its setting in education and so on, there could be like actual consequences of how we spend money if we oversell like how domain general disease or how trainable disease, right? Like for example, in the case of negative evidence for chess and music and working memory training for increasing intelligence, it seems like, you know, money goes to these programs if people think they work, and that's just like a risky move if we are not sure what we're doing. So rather than searching, this comes from the Sala paper, rather than searching for a way to improve overall domain general cognitive ability, the field maybe should focus on clarifying the domain-specific cognitive correlates underpinning expert performance. And I think that maybe this is a good way of ending and saying like, maybe this is how metacognition research can go forward. Maybe we can train within broad domains. Maybe that's the answer. Maybe yes, you can train as long as you stay within perception and within memory and so on. Maybe that could be one way of doing it, like just treat separate domains. Maybe it has to be more fine-grained. Maybe it's within perception, you have to train each domain separately, but that doesn't mean that it's not trainable. It just means that it won't transfer across different areas. And who knows, maybe it's actually very hard to train and it just needs to be like extremely specific for particular features, maybe within vision or memory and so on. And this is something we need to find out, like how trainable it is across different features and which features are relevant ones. Here I'm putting the cognitive ontology that we're used to, right? Like vision and audition and working memory and so on. It's unclear that the brain cares about these things, right? Like maybe what we need to be training is about a hidden feature that we're not super well aware of. This has been shown in like when using deep neural networks, for example, when you train them to classify objects, and they don't use at all anything that we use. They rely on very different features that are completely hidden to us to make those classifications. And I'm wondering if training, we should be a little bit more open-minded and trying to, if we want to train metacognition, for example, we might do it by trying to tap on things that are a little bit more creative, that are classical categories, which are things that maybe the brain care more about. So just to wrap up, I do think that there's a little bit of a stronger evidence if you're domain-specific metacognition. Of course, there's a wealth of evidence of domain generality. But the problem, if you felt some whiplash between like how I was going back and forth between domain general and domain-specific results, that's how the literature feels to me. It's like, oh, it's domain general. Oh, no, wait a minute, it's not. Oh, no, it is. Oh, it's not. And it's really hard to know what to trust. There's no single critical experiment, of course, that's gonna define these or solve this question. But overall, I feel inclined to thinking that we're better off thinking that it might be domain specific and work with that. And there are some consequences of it, of course. It might be harder to get transfer of metacognitive skills across domains, which has been really hard to find. The good outcome is that maybe lesions and aging effects might remain isolated. So you might become worse at doing metacognition in one domain, but the rest are spared. So for example, general metacognitive deficits should be rare, right? If domain-specific metacognition is true. Domain generality and domain specificity may be on a spectrum, and that's really important. Like I've talked about as if they were like two things and whether the answer is one or the other, but this might be just like a spectrum, and there might be like hidden variables that link metacognitive ability across different domains that make it more or less robust, depending on which domain you analyze. And this, of course, has practical effects of domain general metacognition, may be limited, right? Like if as I said before, like maybe there is some domain generality, but how much it matters, it's something that I think remains to be seen. And to actually answer the question of domain generality, we need to test more domains. Like we've been testing vision and working memory, basically. That's it, with a few exceptions of people branching out. But just if you look at the metacognition database, it's fairly obvious that it's mostly those two. So it's a little bit weird to say like, oh, it's domain general, yes or no, based on like studying two domains. And finally, just to say what I said already, I think that we should beware the temptation of the domain general faculty in general. It's tempting, it's exciting to put everything in some category, but I think the mind and the brain might be just messier than that, and we should acknowledge it. So with that, I think that if we pay attention to the Delphic Oracle, that mandate might actually turn out to be a few mandates that we need to satisfy separately. And I want to thank the lab, collaborators, current and past, and just remind everyone that I'm recruiting PhD students. If you want to apply, get in touch. And thank you for your attention.
All right, that was awesome. So if everybody could unmute so we can give fire applause. Thank you.
Thank you so much.
All right. So Steve, could you stop